Ladies and gentlemen, please welcome our next speaker on stage. Rishiraj Acharya, Google developer expert in machine learning.
Hi, hello. So I'm from India, and by my attire, you can probably guess I'm not some kind of a professional guy out there talking professional stuff. Consider me as your friendly neighborhood if you consider India as your neighbor in that manner, friendly neighborhood speaker. So yeah, I'll talk about if this works properly. A brief introduction about me. I am a Google developer expert in machine learning. The first Google developer expert from generative AI as well as Keras in India. I am also a Hugging Face fellow. I have been a Google Summer of Code contributor at TensorFlow. And I'm also a Kaggle competitions master, and I am not an API caller. I am a professional machine learning engineer at this company called Intellitech, where we work with healthcare domain and large language models in general, right? So while working with large language models, we frequently deal with multimodality. Now, you would be asking, why multimodality? Like, what's the need for having multimodal LLMs, right? So, turns out, we as humans, we don't only perceive the world with textual information. Like, you interact mostly with large language models through text. You ask question, it gives you answer, you chat with it. But can that really become your friend? Your friend would be able to see things around yourself, should be able to hear songs that you like, should be able to look at videos that you like watching. So we as humans perceive world with both text, images, audio, and so if I say something like, this cat is a cute animal, we can also show a picture of a cute cat. We can also show a video of a cute cat to express ourselves better. We can also play the sound of a cat meowing so that you can understand how cute the cat might sound like, right? So the idea is, if we as humans interact in this way, our large language models should interact the same way, right? So here comes multimodal embeddings, a necessary step in progressing towards multimodal large language models. So, any idea here what are embeddings? Anyone? Okay, let me tell you, most of you know what is embeddings, just you are not familiar with the actual term. So how many of you had taken maths in 11th, 12th or college? Had maths? Maths background, anything like statistic, basic mathematics? Okay, so almost some, although I am also seeing some people who have not, but I will explain, right? So in maths, when you need to represent like a point in a graph paper maybe, how do you represent it? X comma Y? Because a graph paper is a two-dimensional plane, right? There is this vertical axis, there is horizontal axis. So to represent a point, you represent X comma Y. Similarly, you can extend that to n dimensions. From 2 dimension, you can extend that to n dimensions. And in such a way, you can represent anything as vectors in that n-dimensional plane. So, like maybe I have the word apple, and I have the word orange, and I have the word maybe chicken. So the idea is, in a embedding space, words like apple and oranges should have vector representations which make them fall in a similar place to the vector of a maybe, let's say, chicken. So let's say the word apple and oranges in a 2D graph plane lie in this region, chicken, cows, and such stuff would lie in this region. So they are farther apart, so you can have a sense what I mean by multimodal embeddings. And I spoke about text only till now. You can also have pictures of some other fruits. And the idea is pictures of those fruits should be at a similar location to the text like apples and oranges, right? So previously how we used to approach multimodality was using different encoders for different kind of modalities. So for text, we had one kind of encoder. For image, we had another kind of encoder. For audio, for video. For everything, we had separate encoders. They used to give this one n-dimensional array. And by this n-dimensional array, you can just think of it as x, comma, y in your graph analogy. It's just, it's extended to n dimensions instead of 2. So we had text and encodings, image encodings. And the idea was that these encodings should be at a similar place, right? Similar encoding should be at a similar place. So we used to do that using something called as contrastive learning. So what's that? The idea is that, as I said, similar encodings, so those vectors should be brought together, like their distance should be minimized, and dissimilar things should be pushed apart. So there is this one thing called anchor. Let's say the anchor is an apple. And if you have something like an orange, the idea is it should be pulled together, the distance should be minimized. And if you have something like, as I say, chicken, the distance should be maximized. And we do that for multimodality in this case. So instead of just placing images together, we place images, text, audio together for multimodality part. And the idea is we minimize something called as contrastive loss. If you are interested to know more about contrastive loss, you can have a deep study through it. But I will not bore you with the mathematics of that thing at this session particularly. But yeah. So as I said, the idea was to get the encodings separately from all these image encoders, text encoders and stuff, and then minimize the distance between similar embeddings and or maximize the distance between dissimilar embeddings, right? So one very popular model that was trained using this kind of approach was OpenAI's CLIP model. So you had captions and image pairs, and images with their caption were pulled together, like the distance was minimized, and with different captions, the distance was maximized. So CLIP was trained through this approach, and CLIP is a pretty popular model in machine learning. If you are into machine learning, you must have used CLIP at some point or the other in production. Now, those were the boring stuff when large natively multimodal models or large language models were not into the game. Now, modern large language models are able to take in multimodality natively, like you don't need to have different encoders. So can any one of you name any multimodal large language model, like a large language model that can process both images, text? Anyone, if you have used online or any? Yeah, please go ahead.
Gemini?
Yeah, absolutely. Gemini is Gemini is natively multimodal. Then if you are a ChatGPT Pro user, or if you have used ChatGPT, the GPT-4 version, Then you must have seen that you can input images as well. Images, you can input text documents, you can input audio files. But when ChatGPT was in initial phases, you must have seen that it used to accept only text, right? So because that was the time it was using GPT 3.5 Turbo, which was not a multimodal large language model. But GPT-4 is a multimodal natively, so is Gemini. And so let's understand a bit about how GPT works. Like GPT or any modern large language model, what they do is they progressively predict the next token. So this is known as an autoregressive approach. So maybe you have a sentence like Jack and Jill went up, and the goal is to predict the next word. So to predict the next word, what you do is you take the entire previous sequence into consideration and then predict the next word, that is the. So Jack and Jill went up the. And now to predict the next word, you again take the entire sequence before it, Jack and Jill went up the, and then hill. So you see, you are not predicting the entire sentence at once. You are predicting the sentence word by word, or in this case, technically it's called token by token, right? So if you have used ChatGPT, you must have seen the animation that words are getting printed one after the other. The answer does not come suddenly all of a sudden. So that's also a symbolization of that tokens are getting printed one after the other, right? So this is how GPT works, and on the other hand, we have vision transformers for handling images and stuff. So contrary to how we used to process images previously, vision transformers don't work on pixel level. We do not go through the pixels and take them into consideration. Instead, what we do is we divide an image into multiple parts. And then eventually, the model learns which part to pay more attention to in order for getting an output. So like if you have the image of a cat, to make the model understand that this is the image of a cat, which part of the image you should pay more attention to. So as you might guess, in this case, the face part, this nose and mouth part plays a major role in understanding that this is an image of a cat. So that part must get a higher importance. So this is basically a very vague level understanding of how vision transformers would work. And then they would output the probability of the caption or the word the image might represent. So you will have probabilities in here you can see 1, 3, 7 or 1, but it will generally be in 0 to 1 range to make you understand probability. So you see kitty is probably not visible in the screen, but the word kitty is getting 7 probability. So the highest probability, and this is the picture of a cat indeed. And now once you have a model like GPT, and once you have something like a vision transformer, what we do is visual instruction tuning, right? So like maybe you have a painting of the Starry Nights, you give that painting, the vision transformer gets that painting, and you also give a question like who drew this painting. And this part is handled by the large language model that I said you. And together they are processed together into one single unit, one single projection head, and that gives you the ability to process images and text together, and you get textual output. Maybe Vincent van Gogh was the painter of this painting, right? But now let's come to multimodal RAG, the main topic of this session. You must have got an idea of multimodality and its importance, how the technical things work. So RAG, as my previous speaker also was talking about, RAG is a way to give your data to large language models in order for them to give you answers, right? So although large language models are trained on large corpus of text, it does not have all the knowledge it might require. Like, it does not have access to your private information, your company documents. So RAG is a way to fetch that to the large language model while it gives you answers. And so any basic RAG system consists of 3 stages. First is embeddings, second is a vector search, and the third is the LLM component, right? So the first step, embeddings, was pretty much clear. I was explaining embeddings all along. But the second space, why would you require a vector database? So see, if you have maybe 10 paragraphs and I ask you a question and tell you which of these 10 paragraphs should answer this question, what you can do is go through those paragraphs one by one, read those paragraphs and tell that this is really similar to the question. But now scale that to 1,000,000 paragraphs. You would understand that going through each of those paragraphs one by one would be a very hard thing to do. So that is where modern vector databases come to play. They have various advanced algorithms to match your data at a very fast rate, one of them being approximate nearest neighbor. So you don't need to go through the hassle of matching data one by one. But yeah, it's true that you can also skip the vector database part and handle that manually as well. I have a small demo of everything that I spoke about here. If it's possible to just click the link, I'll just open a collab. And this is a real production application I'm showing you. So if you can get a clear idea of how things work. Anyway, just please keep your questions ready because I want this session to be interactive and you should have questions that I can answer. Anyway, yeah, when I say scroll, just scroll this, okay? Yeah, I don't think it's is it visible? The text is visible from the last? Can you give me a cheer if it's visible? Now give me a cheer if it's not visible. Not visible. Could the font be increased a bit more? Yeah, awesome. Yeah, so we begin by importing our Gemini credentials. We'll be using Gemini Flash model for this. And just scroll down. I'm also importing my VV8 database. This is a real working production app, so I have several thousands of data points. It won't be possible to run them live, so I'm just loading my database from VV8. VV8 is a vector database, multimodal one that I was talking about. Scroll down. Scroll down. Scroll down. Yeah, see, I'm taking my, restoring my backup, client.backup.restore. This is my database that I had worked on previously. Scroll down. Yeah, and now you can see it has an image count of 13394, so over 13,000 images and a video count of about 200. I've stored this in this database, and next I have a function called as retrieve image. So what I do is, if I type a query, this function goes to the database from the VV8 one and gives you the most similar image to that query. So I've typed here fishing with my buddies. So you can see an image. Buddy in this case is a dog, but dogs are buddy, right? So uh, fishing with dog. Now next we have our Gemini configured, so the API key and stuff. And next we have this function called as call LLM. So what call LLM does is, it uses that previous function, gets an image, and also uh, gives that image and the query you have to the large language model. So understand this, if you have a query, that query first goes to the vector database, gets the most familiar image, and now if you have the image and you have the query, those two things are processed together by the large language model, right? So if I now do something like, please describe this image in detail, then you can see things like the image shows a man holding a fish in his hands. So it's just using that image and the query together to the large language model. And yeah, if you scroll down now, you can do things like type pictures like paragliding through the mountain. It fetches the most suitable image from your vector database, and it also describes the image. The image shows a red paraglider soaring over a lush green mountain range and so on. So this is how we would be working with a production grade multimodal RAG system. So yeah, I guess that's it for the demo. Now let's switch back to the original slides. Now we come to the last part of this talk. We will walk through some of the industry applications of multimodal large language models and RAG systems. So one of them is invoice data extraction. Like most of the invoice that we have, if you are a serious business, you would want those invoices not as image files or just text document lying around your office. You want to store that information at a database or process those information. Like if you have some customer information, you want to have that in a JSON format so that you can have insights through that invoice, right? So previously what we used to do was employ a person to just write those information from images to computer, the database guy. But currently you can do that entire processing with just multimodal large language models. You can have JSON extraction from invoices. Also, if you have something like, that's not an invoice but still contains information like infographics. This is the poster of something, an advertisement maybe. So you can have information extracted even in tabular format using multimodal large language models. Also, if you have something like a flowchart, like I'm sure none of you over here can summarize this flowchart and explain to me what it's telling at maybe 1 or 2 minutes. But it becomes really simple with the help of multimodal large language models. So you can have the list of all the things that flow in this chart. And yeah, that's all for this session. If you have any questions, please go ahead. Otherwise, you can follow me through my socials. I still have 5 minutes left. So if you have any questions regarding machine learning in general, AI or ML in career industry, please go ahead. Yeah, please. Mike. But the last row will not be able to hear.
In the case of the receipt learning thing, the receipt analyzing use case that you described, what is the advantage of using a model like you said, rather than using something like Tesseract and then sending the text into, say, Gemini or something like that?
Okay, that's a great question. In my previous company, Intelitech, where I used to work on, I worked on an open source product called Indexify. That's one of the leading platforms doing exactly this document text extraction. So you have models like Tesseract, which would be able to do text extraction from images. But the problem with Tesseract is that it does not consider alignment and text placement into consideration. Like maybe, let's go back to my previous, I'll show you. Yeah, what Tesseract would do is it would simply read the text information line by line. So it would read East Repair Inc., invoice 1912 Harvest Lane, New York, NY. This would be one same block of text. And bill to, ship to, invoice hash US001. This does not convey the meaning to the information that you are getting. You will not be able to get that in a JSON or able to get meaningful insight from those, right? So here you can see you have something like quantity 1, description, unit price, amount. You are having a proper JSON. But with Tesseract, what you will do is you will just get textual information back. And that textual information is just semantically, or what I mean by semantically is just similar things as placed together. You will get just textual information. So that's hard to process afterwards. So that is why multimodal LLMs are special in this case. Yeah, hope that answers. Anyone else with any other question? Yeah, please go ahead.
Hi. In the future, do you think this LLMS would play a major role in cellular studies and even in astronomy?
Yeah, what I saw recently, first of all, where I work in currently, this company called Intelitech Health. So we work exclusively in healthcare domain, and we are production-based company on healthcare domain in Australia. What an interesting thing that I saw after coming to Sri Lanka is there's also a hospital who is doing cancer diagnosis using AI. Just nearby in Colombo, I don't remember the name of the hospital. But that's very interesting to see because we don't see that in India yet. So yes, large language models, in fact, multimodal large language models are particularly good at processing. I would not say large language model in ML models in general. They are particularly very good at this point in understanding or diagnosing cellular things like maybe cancer or such stuff. So yes, it's just a matter of time we figure out the patient regulations, and I believe that healthcare industry will flourish with machine learning models because it provides far accurate information till now as compared to normal doctors who might be biased. Any other question related to, yeah, please, go ahead.
In multimodality, you said that we are storing data in different dimensions. So if I ask something like, what is the companies among the largest techie? So if they say like Apple is there, and I'm asking about what is the newest iPhone. They go to a different dimension and they also get me a Apple logo on there. So aren't we storing the same data in two dimensions, and we are doing storage waste on there?
Okay, so Apple in this case can have different meanings, right? So the idea is Apple can have different meaning. It can be a brand apple, it can be a fruit apple. So the idea is it should take into consideration previous words surrounding words and calculate different vectors for Apple, considering the surrounding words to itself, right? So when you are saying the word bank, maybe bank can mean the bank of a river, as well as it can mean the bank where you deposit your money. So based on the surrounding context, with the attention mechanism that we have in transformers, you are able to give them different meaning based on the surroundings, which was previously not possible with normal models like RNNs or LSTMs, right? So hope that makes sense. If you have any other question, you can just go to this link and ask me on my Twitter or Instagram or any other place. But for now, I'll end my session over here. Yeah, all right. Thank you.
Thank you, Rishiraj, for that fascinating and interactive talk. Your insights about leveraging cutting-edge technologies into advanced search capabilities have truly expanded our knowledge of what's possible in this scope. So to present you with a token of appreciation and to say thank you, now I'd like to invite over to the stage Ms. Lanka Pereira, GDG organizer and WTM ambassador here in Sri Lanka.